Okay, number 19, they give me this position function and they say, suppose the distance of an object from the origin at any time t, where obviously t has to be greater than 0, is given by s of t as defined here. So first problem says, at time 2, is the object on the left or the right of the origin? So they're not asking me anything about the way the object is moving, they're just saying, at time 2, where is it? When they're asking me about location or the position, then I'll simply use the position function. So for A, I'm going to evaluate the position at time 2. If that's negative, that means I'm on the left. If that position function is positive, it means I'm on the right. Pause the video and try this problem yourself. Okay, so we know we're going to evaluate it at 2, so let's go up here, show some work. Okay, so my left-hand side is s of 2, my right-hand side is negative 25. This is telling me that at time 2, my particle is 25 units to the left of the origin. I know it's to the left because the negative indicates that I'm in the negative direction. Okay, so they didn't give us units in this problem, but let's assume that we're talking about meters and time is measured in seconds. So then to add some units to our problems, s of 2 would be negative 25 meters. We're 25 meters to the left. Okay, for part B, it says at what intervals of time is the object on the left of the origin or on the right of the origin? So again, they're not asking when we're moving leftwards or rightward. If they had asked, when are you moving to the left, then I would have used v. So if they'd use this terminology, then I would be using v of t, where it's negative and positive. But since they're just saying, where is the object, we are again simply analyzing the position function. So to know when it's on the left and the right, I'll have to use a number line to find out where it's positive and negative using these same rules up here. So let's find our roots and then stick this bad boy on a number line. See if you can finish the problem yourself. Okay, so I've factored my position function, and by setting it equal to 0, I'll be able to figure out where it flips from being on the left or on the right. So at these three values, 3/4, 3, and negative 3, that's when s of t equals 0. What does that mean? It means that I'm at the origin. So in between these values, I can be either on the left of the origin or on the right, based on the sign. Now, recall that time can't be negative, so let's stop our number line at 0 and cross out the left side. Okay, starting on the right, we have a positive in front, so positive. At t equals 3, actually these are all going to flip, so flip, flip, flip. Okay, here's what we know. From 0 till 3/4, the position is positive. What does that mean? What will we write down? It means that the object is on the right of the origin. Because s of t is greater than 0, but that's not the only place. Also from 3 to infinity. Okay, for the same reason. Then we can say that between 3/4 time 3/4 until time 3, the object is on the left of the origin, since the position is negative. Okay, so let's just copy and paste these into our answer and leave our workspace. Perfect. Next question, C, says, what time is the object at the origin? So again, we're talking about where it's the position. When is the position at the origin? That means the position should be 0. So interpreting this, we're saying, okay, S of t should be 0. Well, we actually have already found our roots. When we set S of t equal to 0 in this step, what were the t values? See if you can write them down yourself. Make sure you crossed out -3 because that doesn't, it makes sense to have a negative time, and 3/4 and 3. So if the problem gave us units, we need to go back and see what's our measurement of time. Indeed, it was seconds. So we'd say at t equals 3 seconds, our object is at the origin, since the position equals 0. Okay, D says initially is the object moving rightwards or leftwards. So this keyword initially tells me that we're evaluating at the start of time, right? At time equals 0. You should always make this connection. Initially, that means time equals 0. Now it says, is the object moving rightwards or leftwards? So which should we be evaluating? Position, velocity, or acceleration? Which one deals with motion, movement, right and left? So we're not going to use position because then the question would have said initially, is the object on the left or on the right? So that's a position question. This question doesn't care where the object is, it just wants to know what way it's moving. So then if we're talking about motion, we'll always go to velocity. We save acceleration for the problems that ask specifically about acceleration, aka the rate of change of velocity, or the questions that talk about slowing down or speeding up. Those are questions that involve acceleration. If it just asks about movement, we'll use v of t. So initially means evaluate the velocity function at 0. And if this is positive, we're moving rightward. If velocity is negative, then we're moving leftward. Let's go ahead and find our velocity function first and then plug in 0. I'll let you pause the video here, try it yourself, and then compare your work against mine. So initially, the velocity of the object is -36. Let's use the proper units. That would be meters per second. We're talking about the rate of change of the position. So what does that mean to answer our question? Are we moving leftward or rightward? Since velocity was negative, we are moving leftward at t equals 0, since v of 0 was negative. Or we could say we're moving leftward initially, since v of 0 was less than 0. So if you did not make this connection here in your work, then you won't get the point for using v in your explanation. So for good practice, let's just always say v of 0, which is s prime of 0, right? The rate of change of position is negative. Okay. Let's do E. It says over what intervals of time is the object moving rightwards or leftwards. So now it wants me to talk about all of the times how it's moving, not just initially. So for this, we'll use a number line. Since it's asking about movement, we'll do a number line for v of t. Okay, we found v of t here in part C. Why don't you pause the video, make the number line yourself, and come to your own conclusion based on what you know about moving left and moving right. So we found that when we set v equal to 0, which, by the way, do you remember what it means when v of t equals 0? It means that what's happening to the particle? Is it going left, right, or just not at all? Yeah, this means that the particle is at rest. So there's 2, we go until 0, and time can't be negative. So at the start, we're positive. At t equals 2, we'll flip. And we can see now that from 0 to 2, the object is moving. Oh, we should label this. And we should also have labeled our initial guy, s of t. Okay, so from 0 to 2, our object is moving leftward. Since v of t, which is s dash of t, is less than 0. So since the velocity is negative. And then from 2 until infinity, our object is moving rightward. Since our velocity, which is the rate of change of position, is greater than 0 or positive. So I'll just grab these and drop them in our answer. Okay, so for F it says, at time 2, is the object moving closer or farther away from the origin? So if my position is positive, then my velocity would have to be negative. That's how I'll be moving closer to the origin. So I just do this quick mental exercise to remind myself my definitions if they're not in front of me. If our position is already positive, so we're on the right, then to move further away from the origin, we'll have to move even further in the same direction. So that means that velocity would also have to be positive. What does that tell us? That means if I want to move further from the origin, then S and V will have the same signs. I want to see what's happening at time 2. So what 2 things should we look at? Yes, we should find the position at time 2. We should also find the velocity at time 2 and then compare the signs. Okay, so I believe we solved for S of 2 before. Yeah, in part A, they said at time 2, where are you? Well, S of 2 was negative 25. We don't have to redo our work if we've already done it. So S of 2 is negative 25. Now let's find V of 2, which we haven't found yet. Okay, I'm just making a little bit of room. Let's do part E and find V of 2. So first, V of t, we found it over here. So let's plug in 2. At time 2, our velocity is 0. Actually, that matches what we had discovered earlier. So at time 2, my object is on the left of the origin, but it's not moving, right? It's not going left. Velocity would have had to be negative, and it's not going right. Velocity would have had to be positive. So then the answer is neither. So basically we're saying at time 2, our object is not moving closer or further away from the origin. It's actually at rest because its velocity is 0. Okay, part G says, at what times is the object at rest? Well, we actually just answered that question. If the object is at rest, what must be true? Well, if it's at rest, it means it's not moving, meaning that V of t equals 0. We have in multiple parts already found out where V of t equals 0 by using when we made our number line here. So this was V of t, and we had set it equal to 0 in this stage right here. We found that velocity equals 0 when time equals 2, and we're done. So for H, what interval of time is the object moving closer to the origin? Okay, since we want an interval of time, we'll have to do our number line. And we're going to consider both S and V as we said before. So if we're moving closer to the number line, think about it, draw a sketch if you need to. What must be true about S and V? Should they have the same signs or opposite signs? So if I'm moving closer, let's take an example. I'm to the right, so S is positive, but to move closer, I have to move to the left, so V will be negative. So S and V should have opposite signs. Okay, let's construct our S and our V number lines and see where they have opposite signs. I'm going to pull them from up here. Okay, so when you draw your number lines side by side, make sure that these numbers are lining up. So 2 is between 3/4 and 3, so that looks good. I don't have to make any changes. And let's drop our perpendiculars. So that's 3/4, that's 2, that's 3. We want to know where they have opposite signs. So that's true in which areas? From 0 till 3/4, they have opposite signs. Between 3/4 and 2, they're both negative, so that's not what we want. Between 2 and 3, they have opposite signs. So our final answer is from 0 until 3/4 and from 2 to 3, since S of t and V of t have opposite signs, and we know that that means they're moving closer to the origin. For part I, at t equals 3, is the object speeding up or slowing down? So for speeding up and slowing down, we look at V of t and A of t. So quickly, if they have the same sign, that means I'm speeding up. If they have opposite sign, that means that we're slowing down. The reason that that makes sense is you can just, like, in your brain, imagine if V of t is positive, it's just moving to the right. So if my object is moving to the right and then acceleration is positive, that means that a force is also pushing it to the right. That's why it'll speed up, because the force is aiding it in the direction it's already going. If they had opposite signs, so let's say our particle was moving right, but then there was a force not going in the same direction, but in the opposite direction, then you're going to get some friction there, and your object will be slowing down. So that's what we'll be looking for. And they're giving us a specific point, t equaling 3. So why don't you pause the video and make this judgment on your own. Be very careful with the algebra. Let's see what happens. So for V of 3, I found that it equaled a positive number. I don't really care what 19 minus 36 actually is. I just want to know the sign. And V of 3 is positive. Your next step should have been to find A of 3. So to find A of 3, first we need to find what A of t is. So this is letter I. I want to find A of 3, so first I'll have to find A of t. Well, A of t is just the derivative of velocity, so I'll write that down. The derivative of my velocity function is 24t, I'm using this here, minus 6. Therefore, A of 3 is 24 times 3 minus 6. So A of 3 is also positive, showing our work here. So moving down here, since both our velocity and our acceleration are positive, that means that our object is speeding up. Okay, for part J, it says, on what interval of time is the object's speed increasing or decreasing? So these are exactly the same thing as saying speeding up, right? Speeding up or slowing down. So we'll, just like before, use A and V to compare. Well, what makes this problem different from the last problem? Because you might be saying, well, if speed is increasing means speeding up, didn't we already answer that question? And The speed decreasing means it's slowing down. We already answered that too. What's the key difference here? So this question is asking about what interval of time. In part I, we just answered the question at one specific time, right? At t equals 3. Now they want to know at all times, when are we speeding up and slowing down? So we'll use our number lines. We'll use our v of t number line and our a of t number line. So v of t number line had a 2, and it was positive to the right, negative to the left. For a of t, we don't have a number line yet, so let's make it. From this section, we found a of t equal 24t minus 6. So setting that equal to 0 and factoring out a 6, we find that the only root is at 1/4. And we don't care what happens to the left. Okay, to the right we're positive, and then we flip negative. And I'm going to bring this number line, label it a of t. I'm going to bring it down to the problem and line up. I'll be speeding up when they have the same sign. So let's write speeding up. Let's see, they have the same sign. Let's extend our negatives and our positives. Okay, so we have 1, 2, 3 different intervals. Now, from 0 to 1/4, they have the same sign. So it's speeding up. In fact, it's speeding up as it moves leftward. It's also speeding up from 2 to infinity. Except it's speeding up this time in the positive direction. It's moving to the right and moving faster to the right. And our explanation there is since A and V have the same sign. Now let's do slowing down. So where are we slowing down? Between 1/4 and 2, which way is the object moving? V of t is negative, so the object is moving to the left. But the force is pushing it to the right. We have opposing forces here, therefore our object is slowing down. Okay, part K. At what time is the acceleration of the object equal to 2? So I'm going to write two things. You decide which one is the correct interpretation of the problem. And I want you to be very careful about where I'm putting the 2. So are we setting up this and solving for t? Or are we setting up this and solving to see what a is? I hope that you had said we are going to set up the first problem. The reason is because they're saying at what time? At what time means we need to find the value of t. At what time is the acceleration equal to 2? Here I'm showing acceleration equals 2. What this is saying is, what is the acceleration? Right? That's why there's a question mark. What is the acceleration at t equals 2, at time 2? That's not what this question is saying at all. So we need to make sure that we are using the first setup. Okay, so at what time? You can immediately write that down like t equals question mark. That's what we're solving for. And then acceleration equal to 2. So we're writing a of t equals 2. Great, so if we're solving for t, we need to go and grab our a of t function. And we just set that equal to 2. Let's move the 6, solve for t. And we're done. So acceleration at time 1/3, or at t equal to 1/3, our acceleration equals 2. And we answered the question. And we're done.